In this video, we are actually going to study the trigonometric ratios of angles which are greater than 90 degrees. But let us recall first what we have studied about the trigonometric ratios of angles from 0 to 90 degrees. What we have studied, if angle is 0 degree, so its sine 0 is 0, whereas its cos 0 is 1. So this is the angle and these are the trigonometric ratios, sine and cos. Then we have studied for 30 degree, then 45 degree, then 60 degree and 90 degree. Now sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1, cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 by 2 again, and cos 90 is 0. Now in this video we are actually going to study what is the trigonometric ratio if given angle is suppose 120 degree. What is its cos value, what is its sine value and other trigonometric values. Suppose it is 300 degree or 240 degree. So what is its cos and what is its sine value? So this teaching video is made to get the answers for these questions. To get the answers, let us understand the geometrical meaning of cos and sine first, and using that concept we will be able to find the trigonometric ratio of any angle. Now what is the geometrical meaning of sine and cos? For that we will use the concept of revolving line. This is the revolving line, this is the Cartesian plane in fact. This is x-axis, this is y-axis, and this is a revolving line or revolving ray whose length is r, and it is making the angle theta degree with the x-axis. It is revolving and forming a circle. We are also assuming this can revolve in both the directions, either anti-clockwise or clockwise. Now, what is the meaning of sine and cos here? For that, we will first form a right angle triangle. Suppose this point is O, this point is P, that is the tip of the revolving ray is P, and we have drawn a perpendicular from P to the x-axis. This point is suppose L. So in right angle triangle, O, P, N, this length hypotenuse is R, this is PN and this is ON, and this angle is theta. We are measuring this angle in anti-clockwise direction. According to the notation, anti-clockwise measurement is considered as positive, whereas clockwise notation is considered as negative. Now, first try to define what is sine theta. Sine theta is opposite upon hypotenuse. So opposite is, suppose Pn, let us assume this as A, and On, this is B. So sine theta will be opposite upon hypotenuse, that is A by R. So we can write A is equal to R sine theta, R into sine theta. Similarly, cos theta can be written as adjacent upon hypotenuse, that is B by R. Therefore, we can write B is equal to R cos theta. Now, what is the geometrical meaning? This much length is B. That means this length is R cos theta, and this length is R sin theta. R sin theta. This is A. Now let us consider this diagram here. So we will consider this much length is R cos theta, and this much length, this length is R cos theta, and this length is R sin theta. Now if I imagine r is equal to 1, r is equal to 1. So we are assuming this as 1. The length of OP is 1. So this length, that is Pn length, will be 1 sin theta and On length will be 1 cos theta. So sin theta is nothing but the projection of or the shadow of OP on y-axis. So this is sin theta if the OP length is 1 unit, whereas On, it is the shadow of OP on x-axis. So On represents the cos theta. It is nothing but the shadow of OP on x-axis. So sin and cos is nothing but the shadow on y-axis and x-axis respectively. So if I consider this theta angle as 30 degree, OP length as 1 unit, so I can say the cos 30, that is this is On, will be root 3 by 2 and sin 30, that is this much length, equal to 1 by 2. So this is the geometrical meaning of sin theta and cos theta. Sin theta represents, so I am actually writing here, sin theta is nothing but shadow of OP on y-axis, and cos theta is nothing but shadow of OP on x-axis. Now using this concept, let us find the different sin and cos ratios of angles which are greater than 90 degree. The first angle that we are actually going to study, that is 120 degree. So first let us move the revolving line by 120 degree. So this is O, this is P. So we have moved the OP with 120 degree. Now how to get its sin and cos? As we have said, the shadow of OP on y-axis will be sin 120 and its shadow on x-axis will be cos 120. Now get these values. We will try to find, let us first draw a right angle triangle here and let us find its congruent triangle. Let us draw its congruent triangle in the first quadrant. So it will be somewhat like this. Now this angle is 120 degree. Naturally this angle will be 60 degree. This angle will be 60 degree. So we can say this much angle is also 60 degree. If it is PON, we will consider this triangle as P dash and N dash. And triangle PNO is congruent with triangle P dash N dash and O. O is common in both the triangles. Now this angle, that is angle P dash ON, both the triangles are congruent triangles, so these two angles will be equal. We are actually interested in these values, this value and this value. So this value can be determined equal to, that is sin 120 can also be equivalent to this much length, that is P dash N dash, whereas cos 120 will be equal to negative of this length, that is cos 120 will be minus of O N dash. That means this much length is actually this much length, but this is on the positive side and this is on the negative side. Now this is a simple right angle triangle where angle is 60. So this much length, which represents the sin 60, will be 1 by 2 and this much length which represent the cos 60 will be sin 60 will be root 3 by 2 and cos 60 will be 1 by 2. So sin 120 will be p dash n dash, that means this much length, this is the shadow, it will be equal to root 3 by 2 and it is also equal to sin 60, whereas cos 120 is equal to negative of on dash which is cos 60, it is 1 by 2, that is equal to minus of cos 60. So using the shadow of revolving line concept, we can determine the trigonometric ratio of any angle which is greater than 90 degree. So here we have concluded that the sin 120 can be considered as p dash n dash. We have considered these two triangles. We have drawn this triangle so that we will able to find length of the shadow of OP dash, OP on y-axis and x-axis. This will be more clear with another example. Let us consider the angle 150 degree. For 150 degree, the revolving line will be somewhere here. This much angle is 150 degree. Naturally, this angle is 30 degree. So again, this is O point, this is P point. Its projection on x-axis will be N. We will draw a right angle triangle. We will draw its another congruent triangle in the first quadrant. Let us name this point as P dash. Let us name this point as N dash. This is 30 degree. Therefore, this angle is also 30 degree. Its shadow on y-axis will be this, and it is the sin 150 as well as it is sin 30. Both are the right angle triangle and both are the congruent triangle. Whereas this will be cos 30 and on dash, on, which is nothing but the cos 150 degree. So cos 150 will be on and sin 150 will be equal to Pn length equal to P dash N dash length. Now sin 150 from this right angle triangle, we have concluded that sin 150 is equal to Pn equal to P dash N dash, that means this much length. It is nothing but it is also equivalent to sin 30, that is 1 by 2. So sin 150 is equal to sin 30 and value will be 1 by 2. Whereas cos 150, that is the shadow on x-axis, will be equal to on, but it is negative of on dash and it is negative of cos 30, that is minus root 3 by 2. So using the shadow concept, we can determine the trigonometric ratios of any angle which is greater than 90 degree. So we have studied how to get, with these two examples, we have studied how to get the trigonometric ratios of angles which are greater than, more than 90 degree. Thank you, students.